Hello, in this video we'll be discussing about basics of functions. Okay, so first of all, what is meant by a function? Function is used to perform a particular task. So after performing the task, the result can be given back to the calling function, okay, or result can be immediately displayed in the existing function. Okay, so let's see here concept of function. Okay, so what is meant by a function? Function is nothing but a block of statements which is used to perform a task. Block of statements used to perform a task. Okay, so in fact, you can consider function itself as a black box. So where you will give the input and it is going to produce the output. Okay, so you pass the parameters to the function which is a black box, and you come up with the result as an output to the black box. Okay, so now in this concept of functions, there are two types basically. One is built-in function. The other one is user-defined function. Second one is user-defined function. So these two are basically types of functions. Okay. So if you observe a built-in function, the action which is performed by the built-in function is with the help of included header file. Okay, so it's like the entire functionality of the built-in function is already defined in a header file, and you need to just include that particular header file and call this built-in function. Okay, so next one is user-defined function. In user-defined function, user is going to write the function, and this function is called by the user, and results will be obtained in another function. Okay, so for example, if you consider built-in function, examples of built-in function are scanf statement, printf statement. In fact, square root function, which is defined inside a header file called math.h header file. Okay, so next one is user defined function. In the user defined function, we are going to implement the entire code which is related to the user defined function, and the same code is called whenever it is required. So the examples of the user defined function can be, for example, search function or sorting function, or it can be tax calculation. Okay, or it can be calculation of marks, calculating average, like this. So these are basically user defined functions which is defined by the user, and also it is used by the user by calling the same function. Okay, like this. So now we'll discuss about the basic components of the function. What are different basic components of the function? So there are 5 components of the function. First one is function prototype declaration. Second one is function call. Third one is parameters which are used in the function call. Okay, and also in the function definition. And the fourth one is function definition itself. Fifth one is return statement. So these are different components that are written in order to write any function. Okay, so let's see here components in a function. Okay, so different components of the function, let me write one by one here. First one is function prototype declaration. Function prototype declaration. And second one is function call. And third one is parameters, which is function parameters. Okay. Next, similarly, fourth one is function definition. Function definition. So this function definition has got two parts. Okay. So any function definition has got two parts. One is function header. We can write function header, and the other one is function body. Function body. Okay. So next, fifth one is a return statement. Fifth one is a return statement. Okay. So these are the different components of the function. So now we need to discuss about each of the component while implementing the function. Okay. So let's discuss about function prototype declaration. Okay. First component, function prototype declaration. Okay. So in this function prototype declaration, we will be explaining the compiler that this is the name of the function that we are going to call, and the return type of the function is so and so. Okay. And also we'll mention what are the data types that are taken as parameters to the function, as well as what are the number of parameters that are passed for the function. Okay. So let's write like this here, data type. Okay, function prototype declaration. So what is the name of the function that we are going to call? Let us suppose, for example, I'll show you here, int max. Okay, so name of the function is max and return type of the function is integer. Okay, now we have three components or three parameters or two parameters, let us suppose, which are int comma int. Okay, so if I write function prototype declaration like this, then what is explained to the compiler? Okay, so what information is known to the compiler after looking at this particular function prototype declaration? So you can observe clearly, this explains name of the function is max. Okay, name of function is max. Okay, so what is the return value of the function or return type of the function? So the return type of the function is integer is the return type. Okay, how many parameters are there? Number of parameters that are passed to this function. So which is nothing but number of parameters are clearly two parameters. Okay, and what are the data types of those two parameters? So you can see both these parameters are integer. First one is integer and the second one is also integer. So all this information is conveyed to the compiler, okay, stating that this is the name of the function, this is the return type of the function, these are the parameters of the function. How many parameters are there? Two parameters are there. And what are the data types of the parameters? Integer and integer. Yes or no? Like this. So this is how it will help the compiler to understand. Okay, so let me write the syntax for function prototype declaration here. Okay, so syntax can be written like this. First you need to mention the return type. Okay, first you need to mention the return type and then write the name of the function. Okay, function name, and next we need to mention the parameters. What are the data types of the parameters? Okay, so return type and then function name and then followed by parameters. Again the parameters corresponding data type should be written like this. Okay, so data type of parameter 1, I can say this is data type 1, and then similarly data type of parameter 2, so and so on like this. So finally we have to mention semicolon. Clear? So I'll show you some examples of the function prototype declaration here quickly. Example, suppose we are performing some operation. Okay, so first example is return type of function sum is integer and it is taking two parameters. One is integer and the other one is also integer. Okay, like this. Similarly, we'll consider the second example. Second example is so let us consider we are going to find the average of three numbers and return this average back to the calling function. So in this case average is a floating point value, so let's take float as the return type of the function. So name of the function, I'll take it as find avg. Find avg is the name of the function, and this particular function is taking three parameters. So those three parameters are integer operands. So int comma int comma int. So these are the different parameters that are passed for this particular function find avg. Okay, and next similarly let us suppose you're taking input as floating point values. Okay, and returning the value is also floating point type. For example, you are going to compute the average among floating point values which are taken as input. Okay, so and also the average that is computed is also floating point type. So in that case how you can write so the return type of such function is also floating point type, and the parameters that are taken to this particular function are also floating point type. So which means you can write float comma float comma float. Okay, like this. So next similarly, for example, you want to return a character data type. Okay, so then the return type will be character data type, and the parameter, suppose you are taking three parameters, all are characters. Okay, so in such case you can write like this: char, name of the function, let us suppose fun, and it is taking three parameters, all are character data type. In that case you can write char comma char comma char. Okay, semicolon, like this. So this is how we can write function prototype declaration. Okay, fine. Now if you observe, after function prototype declaration, the next one we need to cover is function call. Okay. So let's see how function can be called. Okay. Function call. So there are basically two types of parameters. One is actual parameters, the other one is formal parameters. Okay. So actual parameters are those values which we are passing from the calling function to the called function. Okay. And the formal parameters are these variables which are used to hold the values of the actual parameters. Okay. So function call, let me give you an example for function call here. In order to consider an example for function call, first we'll see the syntax for writing function call. Okay. So suppose if a variable, okay, suppose the function is returning a value, then what is the data type? Okay, what is the data type that it is going to return? So, or we can say what is the return type of the function? Okay, so we have to declare a variable under that particular return type and store this value into that variable. Okay, so let me consider an example here. Okay, so first of all, we are calling a function here, function, name of the function, and what are the parameters that we are passing here? Okay, so we can say this is parameter 1, this is parameter 2, and so on, parameter n. Okay, yes or no? Like this. So if you want to pass the n number of parameters to the function call, we can call like this. And also you declare a variable. So data type variable is equal to, okay, function of parameter 1 comma parameter 2 comma so on parameter n. So what is the return type of the function? And the return type of the function and this data type should be matching here. Return type of the function as well as the data type of the variable should be matching clearly. Okay, so in that case you can observe clearly it is capable of holding the return value that is given by the function. Yes or no? Variable is capable of holding the value which is returned by this particular function fun. So let's consider an example for this. I'll consider int a is equal to max of x comma y. Okay, so clearly I'm calling a function called max which is going to identify the maximum value among two given numbers. So x is the first parameter and y is the second parameter. Among these two parameters they are basically copied into formal parameters in the function definition. So after execution of that particular function, it is going to return a value which is a maximum value among two given numbers x and y. So the maximum value will be stored now inside a variable called a, which is integer data type, which is of integer data type clearly. Okay, so this is function call, and now we'll be discussing about the next one, parameters. Okay, so we can say here parameters are of two types clearly. Parameters are of two types. So first one is actual parameters, second one is formal parameters. Okay, so what is meant by actual parameter and what is meant by formal parameter? So the actual parameter means parameters which are in the function call, parameters which are mentioned in the function call is said to be actual parameters. If you consider formal parameters, these are the parameters that are specified in the function definition. Okay, so that is the difference between actual parameter and formal parameter. So let me write the definition here. Okay, Actual parameter means parameters mentioned in the function call or parameters given in function call. Okay. So next one is formal parameters. Formal parameters means the parameters which are specified in the function definition are said to be formal parameters. Okay. So parameters given in the function definition, parameters given in function definition are said to be formal parameters. Okay. So here, while we are working with the parameters, actual and formal parameters, three things we need to keep in mind. One is the number of actual parameters must be equal to the number of formal parameters. Okay. And the second one is the data type of the actual parameter must match with the data type of the formal parameter. And the third one is the variables used for the actual parameter and formal parameter may or may not be same. Okay. So these are the three rules. When we are working with actual parameters and formal parameters, we need to consider these three rules. Okay. So let me explain here clearly. First rule is number of actual parameters is equal to number of formal parameters. Okay. Number of actual parameters is equal to number of formal parameters. Okay. Next, coming to the second one, the data types of the actual parameters must match with the data types of the formal parameters. Yes or no? So we can write like this. Data types of actual parameters must match with the data types of formal parameters. Okay. Actual parameters must be equal to the data types of the formal parameters. Okay. Data types of formal parameters. Okay. Similarly, next one is the names which are specified for the actual parameters may or may not be same with the name specified for the formal parameters. It means either you can take the same value that is specified in the actual parameter, okay, or you can take a separate value or variable name which is in the formal parameter. So it means clearly we can take the same parameter name that is specified in the actual parameter as formal parameter, or we can have a separate variable name for the formal parameters. Okay. So we can write like this, actual and formal parameter variable names. Actual and formal parameter variable names may be or may not be same. Variable names may be or may not be same. May or may not be same. Okay. So we have to consider all these three rules, especially while working with the parameters. Okay. So next, coming to the fourth one, which is function definition. Okay. So when we are writing a function definition, first we need to mention the function header and followed by the function body. And this return statement will be written as part of the function body, so that it is going to return a value back to the calling function. Okay. So we'll discuss both together because return statement is part of the function body itself, right? So let's consider function definition. Function definition So in this function definition, the general syntax, okay, or general format for the function definition is written like this, which is also known as syntax. Okay, first we have to write the return type of the function, right? Return type of the function, and then we have to mention the function name. Function name. Okay. So after writing function name, now write down the formal parameters which are used to hold the actual parameter values that are sent from the function call. Okay. So function name followed by formal parameters. So here again we have to write data type. Okay. Parameter 1, comma, so on, data type parameter n. Okay, clear? Like this. So this is going to be the function header, yes or no? And this will be the function body. So in the function body, we have to write code which is used to perform a task by this particular function. Okay. And finally, we need to write a return statement. So return of, so let us suppose an expression is returned. That is the general syntax of return statement. And always remember, the expression after evaluation, it is going to produce a value. The value should be of type equal to this return type. Okay. So a return statement is basically used to return this particular value which is produced by the expression. Okay. And it is going to return a value back to the calling function. Back to the calling function. So this is the return statement which is used to return a value. It is going to return the control as well as the value that is back to the calling function. Okay. So you can see here clearly this is going to be the entire function definition. In this function definition, you can see this part is function header. This is nothing but function header. Okay. And then this part is function body. This part is function body. Okay. So now let's consider an example for writing function definition, okay, which include return statement. Okay. So consider here clearly example. Let us suppose we are going to perform summation operation. Okay, that is addition operation between the two parameters. So the return type of the function is integer. Okay, and sum is the name of the function. It is taking two parameters. One is int x, the other one is int y. Okay. So within this function, you can see this is a return of x plus y. Okay. Like this. So this is going to be the entire function definition. Okay. So in this function definition, you can see up to here, it is going to be function header. Function header. And this part is said to be function body. Said to be function body. Okay, so now within this function body we have a return statement here. So this is return statement and this is the expression. Okay, so this is said to be a return statement. And next, writing x plus y is the expression evaluated, right? So this is the expression that is evaluated first, and the value is returned back to the calling function. Okay, so x plus y, where x is integer and y is integer, after performing addition between x and y, which is x plus y, this is going to return an integer value, and the return type of the function is also integer. Yes or no? So the return type of function sum is integer and the parameters are of integer data type. So when you add those parameters x and y, you will get an integer value back to the calling function. Yes or no? So always remember, return statement is used to return a value back to the calling function. Okay, and inside a return you can actually write a value directly, or a variable or an expression which is evaluated, and it will return a value back to the calling function. Okay, so just like this. Now we'll consider the entire concept of function and its components. So I'll use this concept of functions to write a small program, okay, using functions. So the program is you need to find out the maximum value among two given numbers. Maximum value among two given numbers. Okay. So for that purpose, let me write the entire program. Okay. First, include the header file. So after including the header file, now we can actually use the function prototype declaration. We can use function prototype declaration. So name of the function I am using here is max. Max is the name of the function, and the return type of the function is integer. So max and its corresponding return type is integer. Now it is taking two parameters. So integer and integer, both the parameters are of integer data type, right? Okay. And now in the main function, okay, you can call this particular function. Okay. So let's write main function here. So within this main function, let me consider two variables like int, okay, x comma y, x comma y. So again we are taking big as another variable. Okay, big is another variable which is used to hold the biggest value among x and y after getting the result. Okay, so first of all we need to read this x and y value at runtime. Okay, so it should be printf enter any two values, enter any two values. So once you enter those two values, using scanf statement we can read those two values. Okay, so percentage d address of x comma address of y. Okay, so after reading these values x and y, now you need to call this function. So what is the name of the function that you have taken? Max is the name of the function, right? So let me call this max function by passing actual parameters as x and y. Okay, so and it is going to return a value also back to a variable. So big is equal to we are calling a function called max, and the parameters x and y are passed here. Okay, so finally, after getting the maximum value, we can display as part of output here, printf maximum value is equal to, what is the maximum value that we are going to display here? So maximum value is computed and it is stored inside a variable called big. So let's display big is its corresponding variable. Okay, so now let's implement max function. Okay, so how we can implement this max function here? Okay, what is the return type of the function? First of all, you can see here, you keep this in mind. What is the name of the function? Name of the function is max. What is the return type of the function? Integer value it is going to return. And what are the parameters that this max function is taking? Integer parameters. Okay, how many parameters it is taking? 2 parameters. So by keeping all these things in mind, now let's implement this max function. So int is the return type of the function, which is max. And what are the parameters of this max function? So the parameters of this max function are integer, okay, int x and int y. So as per the rules of the parameters, okay, so the actual parameter name can be equal to the formal parameter. Clear? So now in this particular function we have to implement, okay, and identify the maximum value among two given numbers x and y. Okay, so that particular functionality must be done here and the value should be returned back to the calling function. Okay, so how this can be implemented? For example, consider int large. I'm considering int large as a variable, okay, which is holding the largest value among x and y, so that I can return this large value back to the calling function. Okay, so how we can implement this? You can see if x is greater than y, if x value is greater than y, we can write large is equal to x. Else, if this is not the case, then we can write large is equal to y. So finally, you can see when x value is greater than y, we are capturing x value into the variable called large. If this is not the case, then we are capturing y value into the variable called large. Finally, we have to return the large value back to the calling function. Okay, so here we can return large value back to the calling function, return of large. Okay, just like this. Clear? So now from this you can easily identify what are the actual parameters, what are the formal parameters, everything from this particular program. I'm going to explain each and every component with this particular example. So listen carefully here. First one, this particular statement, okay, is representing the function prototype declaration. Okay, this is representing function prototype declaration. Okay, so next, big is equal to max of x comma y. Okay, so this is said to be a function call. Yes or no? This is said to be function call. Second component that we have discussed about components of the function, right? Function call. And the third component is parameters. Again, these parameters are classified into two types, actual, the other one is formal parameter. So if you observe this, these two are called as actual parameters. Actual parameters. Okay, next, Now you can see here, this is the formal parameters. Okay, here this x and this y are said to be formal parameters. Okay, so if you consider this particular function, okay, in this particular function, first statement, okay, so this is said to be function header, function header. Okay, so within this function header, this int is returning. Okay, int is representing the return type. It's basically returning an integer value. Okay, and this max is representing the name of the function. Yes or no? So max is representing function name. Function name. Okay, and these are the two parameters, formal parameters x and y, isn't it? Now after this, from here to here, this is said to be function body. Okay, function body. So within this function body, this is representing the return statement. Okay, so this is representing a return statement, and what is it going to return here? So this is returning a value which is stored in a variable called large, and this large is computing the largest value among x and y. Okay, yes or no? So these are different function components that we have written in this particular program. Okay, so now let me explain what is the output produced by this particular program. Okay, so first of all, it is going to prompt the message saying enter any two values. Okay, so it is going to display this particular statement, enter any two values, and then x and y values. X and y are the two variables, okay, which are going to used for storing two values that are entered by the user. Okay, so the moment you write int x comma y, it is going to allocate a memory for variable x and also memory for variable y. At the same time, int big, so this is going to allocate memory for variable called big as well. So let us suppose user has entered two values. The entered two values are, first value is 200, second value is 100, let us suppose. So then first value 200 will be captured inside a variable x, and the second value 100 will be captured inside a variable y. Okay, so now max of x comma y, we are calling a function called max here with the parameters x and y, isn't it? So immediately this max function will be called. Okay, so where is this max function that we have written here? So this is the max function, right? And immediately those actual parameters that we have passed are going to be stored inside the formal parameters x and y. Okay, so then you can see those formal parameters x and y are, x value will be 200 and y value will be 100, because you can see the same values that we have considered here also. X value is 200, y value is 100. Okay, and now we are calling this particular function called max. Here also x value is 200 and y value is 100. Now you look at this particular condition, 200 greater than 100, condition true. Since this condition is true, we are going to store this largest value among x and y into a variable called large. So large equal to 200, large equal to 200. So immediately else block will not be executed and it is going to return this large value. What is the large value here? 200. Back to the calling function. So when it is returning back to the calling function large value, then you can see 200 will be stored inside a variable called big. So big value becomes 200, and finally this is going to display maximum value is equal to 200 because big variable contains 200 right now. Okay, so these are all different components of the function and how this execution or function calling happens while working with a function like this. Okay, in this video we're going to discuss about categories of functions. So what are different categories of functions with respect to parameters and return values? Okay, so we can classify these functions into four types here. First one is function with parameters and return values. Second one is function with parameters but no return values. Third one is function with no parameters but return values. Fourth one is function with no parameters, no return values. Okay, so we can also use the word called arguments in place of parameters. Okay, so let me classify the categories of functions here. Okay, categories of functions. So in this categories of functions, we can classify them into clearly four types. Okay, so what are different types here? Very simple. Arguments or parameters we'll consider, and also return values, and also return values. Okay, so we can totally classify them into four types. So function with arguments and with return values. Okay, function with arguments and no return values, function with no arguments and return values, function with no arguments and no return values. Okay, so these are the four types or four categories in which we can classify the function. Okay, so now I'll consider writing a program with respect to each type of this function. Okay, so let me clearly write here categories of functions. Okay, based on this, first one is function with arguments, function with arguments and return values. Okay, second one is function with arguments but no return values. Okay, function with arguments but no return values. But no return values. Okay, and similarly third one is function with no arguments but return values. Okay, function with no arguments but return values. And the fourth one is function with no arguments and no return values. Okay, function with no arguments and no return values. No return values. Okay, like this. So now we'll be discussing the first category of function, that is function with arguments and return values. Okay, with an example. So let's discuss here function with arguments and return values. Okay, so you can see here clearly, we'll consider a small program in order to discuss this particular concept. Okay, so for example, sum of two numbers, sum of two given numbers. Okay, so I'll consider the arguments and return values here clearly. First of all, hash include stdio.h. Okay, so one more thing is, suppose you want to skip the function prototype declaration. If you want to skip the function prototype declaration, in that case, you can write the entire function before the main function. Okay, just like this. Here I'm going to write the entire function implementation of sum before the main function, just like this. Sum of, okay, int x comma int y. Okay, so return x plus y. Okay, so now we'll consider a main function for this purpose. Okay, so in the main function, we are considering two variables here. Let us suppose a is equal to 10 and b is equal to 20. Okay, and now I'm considering a variable called result. Okay, int result is a variable. Now we are returning value back to the result variable. Okay, by calling this particular function sum of a comma b, and finally the variable result is displayed. Printf result is equal to %d. We can display this particular result variable value. Okay, just like this. Now you can see here a is equal to 10 and b is equal to 20. Okay, so how this function calling happens, and why this particular program comes under function with arguments and return values. Okay, first of all, when we are calling this particular function called a sum, we are clearly specifying the arguments a comma b and their respective formal parameters x and y. So therefore there are arguments and also return values. You can see it is basically returning a value back to the calling function. Okay, so let's see how this particular program is going to be executed. Okay, first the program execution starts from the main function. Okay, then it is going to create two variables a and b. Okay, so you can see here value of a is 10. Okay, a value is 10 and value of b, how much is b value? 20. Now it is going to create another variable which is of integer data type, int result. So this means result is going to be another variable here. Now result equal to sum of a comma b. You can see we are calling a function called a sum. Okay, and value of a is copied into parameter x and value of b is copied into parameter called y. Okay, so you can see here x value is 10 and y value is 20. Okay, so now this is going to return x plus y. X plus y means 10 plus 20, value will be how much? 30, right? So this is going to return value of 30 back to the calling function. It means value of 30 is going to be copied into a variable called result, because this is a function call, right? Okay, so result holds value of 30. Now finally it is going to display result equal to 30 as output. Clear? Just like this. So this is an example for function with arguments and return values. Okay, so now we'll see the second type, which is function with arguments but no return values. So we are going to consider the same program, that is function which is performing sum of two numbers, but we will implement with this model, that is function with arguments but no return values. Okay, so let me write here function with arguments but no return values. Okay, now in this example we are going to specify the arguments while calling the function. Even we specify the arguments as parameters for the function definition, but there are no return values. That means called function is not going to return a value back to the calling function. Called function is not going to return a value back to the calling function. So let me explain here. So consider this is a calling function, and respectively consider its corresponding called function here. Calling function and its corresponding called function. Okay, so in the calling function we are basically calling a function. Okay, so like for example we have to mention the function call here, right? Function call must be mentioned. So for example I'm calling a function like fun. So parameters are like p1 p2. I'm passing parameters p1 p2. Okay, so immediately this particular function should be called, and this is function. Okay, and its corresponding formal parameters are f1 f2 with a corresponding data types are implemented here. Okay, so you can observe here clearly this is passing the parameters okay, p1 p2 into f1 and f2, and after execution of this particular function it is not returning a value back to the calling function. Okay, it is not going to return a value back to the calling function, so which means but no return values. Yes or no? Only here you can see here the data and control both are moved from the calling function to the called function. Okay, but after execution of this particular function only control will be returned back to the calling function. Okay, data is not going to be returned from the called function to the calling function because there is no return value here. Okay, so in the previous case of function with arguments and return values, you can see here both control and data are returned back to the calling function. Okay, so since you are not going to return any value, so we don't need any variable to store that particular value. Okay, so let's implement a program with respect to this type. Okay, first include the necessary header file. Okay, and now we are calling a function which is sum. Let's implement sum function here. Int a comma int b. Okay, so this sum function is not going to return a value back to the calling function, so there is no return statement at all in this type. So we have to display the value here. So how we can display the value? So printf result is equal to percentage d. Okay, and you can see here clearly a plus b is the corresponding result. Okay, so now we'll see the calling function implementation, which is the main function implementation. So in the main function, we are going to consider two variables, like for example, int x equal to 10 and y is equal to 20. Okay, and we are simply calling the function. We are not going to return any value back to the calling function here. So just call this particular function called sum by passing the parameters x and y. Okay, sum of x comma y, and then it is going to display the result. Yes or no? So that's it. Clear? Now, if you look at the execution sequence of this particular implementation, okay. So in the main function, you are creating two variables, x and y. Okay. So the value of x is taken as 10 and the value of y is taken as 20. Yes or no? And now we are calling the function sum by passing the parameters x and y. Passing the parameters x and y. Now value of x is passed as first parameter and it is stored in a variable called a. And value of y is passed as the second parameter and is stored in variable b. Okay. So now this is going to create two variables which are basically the formal parameters a and b. Okay. A value is how much? 10 and b value is 20. So finally it is going to display result equal to a plus b. It means in the output screen, okay, you can see the result as a result is equal to a plus b. 10 plus 20 value is 30. Okay, so just like this. So this is clearly function calling and function implementation with the model called function with parameters but no return values. So there is no return statement at all in this function called sum. Yes or no? So it is just displaying, instead of returning a value back to the calling function, it is simply displaying the result. Okay, like this. So next one is third type. If you look at this third type function with no arguments but return values, it means we are not going to pass any arguments to the function, but we are going to get the return value back to the calling function. Okay, so let me explain here function with no arguments but return values. Okay, so let's implement this particular model. Okay, so before implementing, first see how this is going to work. So consider this is the calling function. This is calling function. And coming to the next function, which is called function. This is the called function. Okay. So in the calling function, function with no arguments, arguments we are not going to pass, but it is going to return a value. Okay. It means, let us suppose in the calling function you are simply calling the function called fun, and you are not at all passing any parameters here in the function. Okay. So but it is going to return a value. It means, you can actually implement like this. For example, int fun. Okay, since there are no parameters, you don't need to take any formal parameters here. So but finally you need to return a value. Yes or no? Return value. Okay. So if you observe the flow of control and data between these two functions, that is calling function and the called function, clearly. Okay. So from the calling function to the called function, only the control is traversed. Okay. So control is transmitted from the calling function to the called function. So after execution of the function fun, now along with the control, data is also returned. So in order to hold that return value here, consider any variable like L. L is equal to, okay. So in this mode of transfer, you can see here clearly both data and control will be transferred back to the calling function. Both data and control are transferred from the called function back to the calling function. Okay, just like this. Now let's implement this function with no arguments but return values similarly. So first, consider the header file. And the function is not having any parameters. So let's implement like this. Function name is sum, and it is not at all taking any parameters, right? No parameters. Then here only you can take variables like int x equal to 10, y is equal to 20 within this function. Okay. So and then you can return the values back to the calling function, like return of x plus y. Okay. So similarly we can implement the main function where you are going to call this particular function called sum. Okay. So how you can call this particular function sum is, here you take basically a variable which is holding the result. Okay. Result. Okay. So result equal to, call this particular function which is returning a integer value. Sum is the name of the function and the return value is integer. So finally we have to display this particular result. Printf result is equal to percentage %d result. Okay, like this. So now, so let's see how this is going to be executed. Okay. So program execution starts from the main function, right? And result is a variable. So this is going to create a variable called result. Okay. And now this is calling a function called sum. Immediately whenever the function is called, its control is transferred to execute that particular function, isn't it? So once the control is transferred, it will execute the block of statements inside this particular function. So int x equal to 10 and y equal to 20, it is going to create two variables. Variable x is holding value called 10 and variable y is holding a value called 20. Now it is performing return of x plus y, which is a 10 plus 20. Okay. So 10 plus 20 value is equal to 30. So this value of 30 is returned back and it is going to be stored inside a variable called result. Okay. So finally, this output will be displayed here. Clearly in the output, you can see result is equal to, okay, So 10 plus 20 is 30. So this is the output that is displayed here. Okay. So you can clearly observe while calling this particular function sum, we are not passing any parameters to that particular function. But while the control is returning back to the calling function, which is main function, it is returning a value back to the calling function. Okay, just like this. So next, coming to the fourth type, which is function with no arguments and no return values. Okay, so let's implement this function with no arguments and no return values. Again, in this function with no arguments and no return values, okay, no return values, okay. So clearly there are two functions that we are going to consider. One is the calling function, the other one is called function. Okay, so this is calling function. Okay, and next one is called function. Okay, so in the calling function, when we are calling a function, we are not going to pass any arguments. Okay, so it means let us consider calling a function is like this: function fun. Okay, that's it. So now if you implement this particular function again, this will be implemented like this: function fun. Okay, and there is no return value also, because no arguments and no return values is given. Okay, so you can observe here calling this particular function fun, okay, will activate this particular function. And what is the return type of this function? Void. So void represents return nothing, right? Okay, void represents an empty data type, so which returns nothing. So while moving from the calling function to the called function, no data is transmitted, only control. Only control is transmitted from the calling function to the called function. So after execution of the entire called function, again the control is only transferred back to the calling function. So we can say this is only control transferred. Only control is transferred back to the calling function. Okay. So let's implement this one. Okay. Let's consider the same example. Okay, and the return type of that particular function called sum will be void. Okay, and within this sum function, okay, so we are going to consider two variables like x equal to 10 and y is equal to 20. Okay, so this is going to display that particular sum. Okay, because it is not going to return value back to the calling function, right? So we can say clearly printf result is equal to percentage d x plus y. Okay, so now you can see in the main function we are calling this particular function called sum. Okay, that's it. The rest of the action is performed by the function called sum only. Okay, so let's see how this is going to work here clearly. So execution starts from the main function, and the main function is simply calling function called sum. Okay, so immediately the control will be transferred to the sum function, and within the sum function there are two variables, one is x, the other one is y. So x value is 10 and y value is 20. Now result equal to x plus y, 10 plus 20 value is 30. It means in the output it is going to display a result equal to 10 plus 20 value will be 30. Okay, like this. Clear? Now we'll discuss about local variables and global variables. Okay, how can we declare these local variables and how we can access them? At the same time, how where we write these local variables and global variables in the program. Okay, so let's discuss about local variables and global variables. And global variables. So what is meant by local variable? Local variable is basically defined within the function. Yes or no? Whereas global variable is defined above all the functions, where every function will be able to access it. Okay. So you can see here defined inside a function. Defined inside a function. And if you observe the global variable, these global variables are defined above all the functions. Okay, or we can say outside the function. Okay, so next, what is the accessibility of the local variable and what is the accessibility of the global variable? So if you observe the local variable, it is accessible within the function, whereas the global variables are accessible to all the functions, or we can say entire program. Okay, so local variables are accessible within function, whereas global variables are accessible to the entire program. Okay, accessible in the entire program. Next, so when is this local variable are created? Okay, so whenever a function is called, if you have a local variable inside the function, okay, so the moment function is activated, this local variable will be created. Yes or no? So created and destroyed. Okay, in the function. Okay, so we are basically creating the local variable inside the function and it is going to be destroyed. Okay, once the function execution is over. Yes or no? So next, coming to global variable. Okay, this is created and destroyed. So the moment global variable is accessible to the entire program. Yes or no? So we can say such variables are created and destroyed till program ends. Okay, so or we can say when the program execution starts, these global variables allocated or corresponding memory is allocated and they are destroyed once the program ends. Okay, so we can say destroyed when program execution ends. Program execution ends. Okay. So that is a basic difference between local variables and global variables. Okay. So now you can see here clearly, we'll write an example for the local variable. Okay. So in case of local variables, we are going to use these variables inside the function. You cannot access these variables outside the function. Okay. So let me give you a small example here. Include stdio.h. I'm including the header file here. Okay. Now I'm writing a function, a sample function like void fun1. Okay. And here I'm using int a is equal to 10. Okay. So then print a value. Print a equal to %d/n a. So now I'm going to write the main function. From the main function, I'm going to call this function fun1. Okay. So in the main function, so let's consider int a equal to 100. Okay. And call this function fun1. Then print value of a. Printf a is equal to %d/n a value. Okay. So clearly this is the program, and you can see in this particular program what are the local variables. Here a is a local variable. Okay. A is clearly a local variable. Okay. And then within this main function, again there is another variable which is a, whose value is 100, and this is also a local variable within this particular function. Okay. So now inside the main function we are calling function1. Inside the main function we are calling function1. So calling function1 will move the control to the respective function called fun1. Okay. So now int a equal to 10, it is going to create a local variable within the function called fun1, and its value is assigned to 10. A is equal to 10. So after fun1, now it is going to print value of a. So you can observe here a is equal to 100. A is a new local variable within this main function, you can see, and its value is 100, right, already. Okay. But calling function1 is going to create another local variable whose value is 10, and the name of the local variable is a. Okay. So now this is printing value of a. It means in the output a is equal to, okay, 10. Once the fun1 is executed, now we have another printf statement. This is going to print a is equal to 100. Why? Because this a is local variable and its access is within the function called fun1. Okay. So you can't get this value here until unless you return this value back to the calling function. Okay. So the accessibility or the memory that is allocated for variable a within function fun1 is here, and it is going to be destroyed once the control returns back to the main function. Okay. So once the control returns back to the main function, then there is another printf statement which is printing value of a. So within this main function, value of a, how much is value of a within this main function? 100. So a is equal to 100. You can see a is equal to 10 and a is equal to 100 are displayed as output. Clear? So now We'll see an example for global variable. Okay. So global variables are basically declared in the global variable declaration section that we have already discussed while going through structure of C program. Okay. So here there is a header file available. Now in the global declaration section, we are declaring a variable int a is equal to 10. Okay. And let me write another function like void function fun. Okay. So a is equal to 100. Printf a is equal to percentage d slash n a. Now in the main function, first of all, we are calling function called fun. Then we are printing value of a. A is equal to percentage d slash n a. Okay. So when we write function like this, okay, containing fun, so you can see what is the global variable here clearly. Okay. So within this particular program, you can see this part is the global variable. Okay. We can say this is global variable. Okay. And main function is calling function fun. Main function is calling function fun. Okay. So already we know the moment a global variable is allocated. Okay. A is a variable which is globally declared and its value is 10. Okay. Now within the main function it is calling function fun. Okay. So the moment function fun is called, you can see the code inside function fun will be executed and a is equal to 100. So value of a, that is 10, is modified to 100. Okay, because these global variables are accessible in the entire program. Yes or no? Local variables are accessible within the function, whereas global variables are accessible in the entire program. So the moment a is equal to 100 means this a and this a are same. It is referring to this particular a. So a equal to 100, value of a is modified to 100. Okay. So and then it is printing value of a. When it prints value of a, you can see the output clearly showing a is equal to 100. Okay. So after execution of fun, now control returns back to the main function and it is basically printing value of a. Printing value of a. So how this value of a is printed, you can see already the updated value of a is 100 right now. So a value will be 100 again. So very simple here, this value of a equal to 100 is printed by this statement and this value of a is equal to 100 is printed by this statement because global variable is only one. So any function that is modifying this global variable will automatically reflect in that particular memory location, and which is subsequently accessed by any other function, then the value will be reflected automatically. Yes or no? So now I'll write a program which contains both local variables and global variables. Okay. So let's implement a program which contains both local and global variables. Okay. Consider like this, header file, first of all. Okay. Int x is equal to 100. Okay. Void fun int y is equal to 200. Okay, now printf percentage d x plus y. Okay, now you can see in the main function we are writing a int y is equal to 20. Okay, and x equal to x plus y, and now printf percentage d x plus y. Okay, and after this you can see here we are basically calling a function called fun. Okay, so let's see execution of this particular code. Okay, so first x equal to 100, it is a global variable, right? X value contains 100, which is a global variable. Okay, so this is clearly global variable. Okay, and now this is a local variable. Int y equal to 100 is clearly a local variable. Okay, next similarly here also int y equal to 200 to 20, y equal to 20 is also a local variable. Okay, now you can see here clearly in the main function int y equal to 20. Okay, the execution starts from the main function, isn't it? So x equal to x plus y. Within the main function there is no local variable with the name of x. Okay, so it means the moment main function is referring to x represents the global variable. Okay, so x equal to x plus y, it means 100 plus 20 value becomes 120. Okay, it means this x value, which is a global variable value, is now modified to how much? 120. Okay, so then it is printing x plus y as output. It means in the output it is going to print x plus y. What is x value? X value is 120, and what is y value? Within this main function y value is 20. Okay, so 120 plus 20 value will be how much? 140. So then it is calling a function. The moment function fun is called, the block of statements inside function fun will be executed, and you can see y value within this function fun is 200, and then it is displaying x plus y. Okay, so which means the updated value of x is 120. Okay, 120 plus what is y value within this function fun? 200. So the value will be 320. Okay, so it is going to display a value called 320 here. Yes or no? Like this. So in the output you can observe 140 is the statement which is displayed by this particular printf, and this printf statement is going to display 320. Okay, as the updated value of x is taken into consideration, and y value within this function is a global local variable which is 200, right? Okay, so like this is an example for local and global variable. Now we'll consider one more example. So with the same name of local variable and same name used in the global variable, in that case what happens, that we will see now. Okay, so consider including the header file first, stdio.h. Okay, now int x equal to 100. Okay. In the main function, we are creating a one more variable with the same name, int x equal to, okay, 25. Now when you print value of x here, percentage d x, then what is the corresponding output displayed by this particular program? Okay, clear? So just check over here, clearly x equal to 100 is a global variable, whereas the main function contains int x equal to 25, which is a local variable. Okay, so int x equal to 100 is a global variable, and within the main function int x equal to 25 is a local variable. Okay, so now if you observe here clearly, initially x equal to 100 is a global variable. Okay, and the main function is creating a local variable which is accessible within this function. So within this function it is creating a variable whose value is 25, and the name of this local variable is matching with the name of the global variable. Okay, so when this happens, always remember, okay, the whenever local variable name and global variable name are matching, and if you're trying to print that particular variable name value, okay, then it will get the local variable value only. Okay, then it is going to get the local variable value. So which means x, when it is printing value of x, it is going to display 25. Okay, because in the main function, when you're asking about x, first it will search whether the value of x is existing within the local variables. Okay, so since local variable named x is existing, it will immediately fetch that particular x value and it is going to display it. Okay, just like this. Hello guys, now we need to write a program which contains a function that is going to check whether the given number is even or odd. Okay, remember we need to write a function to perform this particular task. Okay, so in order to write a function which checks given number is even or odd, first of all we need to consider the header file and then name the function. Okay, let us suppose name of the function is check even odd. Okay, name of the function is check even odd. Okay, so for this particular function I'm passing a parameter and name of the parameter is considered as n. Okay, so now this particular function is going to check whether the given parameter is even or odd. Okay, so in order to check given value is even or odd, we can just simply write like this: if n mod 2 double equal to 0, in this case we can say given number n is even. Okay, so we can write like this: printf percentage d is even. Okay, in the else case we can print odd number, that is percentage d is odd. Okay, so this is the name of the function, which is check even odd function, isn't it? Now we have to write the main function in order to call this particular function. Okay, So let me write the main function here. Okay. So I'm going to use this particular space for explanation. So here I'll write the main function. Okay. So in the main function, we can prompt the user to enter value of n. Okay. And we can call this particular function check even odd function. Okay. So here we'll take a variable called n and we'll prompt the user to enter value of n. Okay. Printf enter any value. So once the user enters the value is read into a variable called n, that is scanf %d address of n. Now we can check whether n is even or odd. For that purpose, we can call this particular function check even odd. Okay, by passing this particular parameter. So we can write like this: check even odd of n, and then close this particular main function. Okay. So now let's see this particular execution sequence. As we know, the entire execution of this particular program starts from the main function. Okay. So int n, which means this is going to create a variable with a value. Okay. Which needs to be taken at runtime. Yes or no? It means now when the user is prompted like this, so this is how the output works. In the output screen, you can see user is prompted like this: enter any value. Okay. So let us suppose value entered is 12. This 12 will be stored inside this variable called n, because you are reading into variable n. Now this particular function is called check even odd function. And what is the name of the parameter that we are passing here? N is the name of the parameter. So n will be copied into variable n. Yes or no? So you can see here this value of n is clearly copied into this particular variable. Okay. Now you can see value of n is 12, and the same is tested here. 12 mod 2 double equal to 0. So when we divide 12 with 2, the remainder will be 0. When the remainder is 0, it is going to print output. So the output printed is 12 is even. Okay. 12 is even. Okay. Like this. Suppose if you are taking any odd value like 13, for example. So in that case, 13 mod 2 double equal to 0, this condition will be false. It will go to the else block and it is going to print 13 is odd. Like this. Okay. So now, similarly, we'll see the next program here. So the next program is clearly, we need to write a function to find maximum among three given numbers. To find maximum among three given numbers. So basically three given numbers are considered. So three numbers are taken at runtime and passed to the function. So let's start writing this code. First, include the necessary header file like hash include stdio.h. Then, now consider name of the function is find large. Find large is the name of the function, and it is taking total of three parameters a, b, and c, because it is going to compute the maximum among three numbers, right? So when we consider like this, first we can write the condition as if A greater than B logical and A greater than C. Okay. So in this case we can print A is maximum, isn't it? So let me consider another variable called max here in order to store the maximum value. So I can write max is equal to A here. Now going to the else if block, here we can write one more condition like B greater than A logical and B greater than C, for example. And then here we can write max equal to B. Finally, in the else case, we can write max is equal to C. Okay, like this. So similarly, next we can write the corresponding main function, okay, where we can call this particular function. So let me consider main function code here. In the main function, so we can take three different variables. Let us suppose again A comma B comma C. Okay. So now we can prompt the user to enter maximum value. Okay. So you can actually print maximum value here immediately. So once you are able to find this maximum value, right, then write a printf statement in order to print max value. Okay, just like this. So now we can prompt the user to enter value of A, B, C. Okay, so we can ask the user to enter any three values. Okay. So once the user enters values, the values are basically stored inside these variables. Address of A, comma, address of B, comma, address of C. Okay. Once the values are taken into respective variables, now we can call this particular function. Okay. Name of the function is find large function, which is taking parameters as A, comma, B, comma, C. This is the main function, isn't it? So like this. Now let's see how this particular program is going to work. Okay. So first in the output screen, you can see enter any three values statement printed, because as we know, the execution starts from the main function, and this printf statement is going to print enter any three values. Then using scanf statement, you can read A, B, C values. Okay. So let us suppose user has entered values like this 10, 5, 9. Okay. So then when the function is called, find large function is called by passing the parameters A, comma, B, comma, C, then the same values are getting copied into A, B, C, which are the formal parameters in the find large function. Okay. So overall we can say variable A is storing value of 10, variable B is storing value of 5, and variable C is storing value of 9. Okay. Now if you look at this particular condition, so you can see the condition will be like this. First condition 10 greater than 5 logical and 10 greater than 9. So 10 greater than 5 condition is true. 10 greater than 9 condition is true. True logical and true will be evaluated to true. So the associated statement will be executed, which means max variable will have a value currently A. Okay. So what is the value of A here? 10 is the value of A, and finally it is going to be printed. So the answer printed will be 10. This is going to display the largest element among the three given values. Okay, just like this.